But someone somewhere is trying to make money. So, if you look at the handout from yesterday, we covered this slide, correct? Okay. You'll notice what I handed out today overlaps the rest of yesterday's paper. So if you look at yesterday's handout, where it says wind indicators, yesterday's handout, just cross out wind indicator and lower, because I revised it. Can I borrow this for a second? Yes. Yes. So that means that we're only going to take notes on that first half of that page that says 04B airports. So that's yesterday's paper that says 04B airports. You can cross out the bottom half where it says wind indicators and that. So the new piece of paper I just gave you starts with wind indicators. All right, so there are effectively 3 types of wind indicators you're going to find at airports that are visual indicators. That is, you don't have to have a radio. You can just look at something on the airport. It tells you which way the wind is blowing. So let's take a peek at windsocks, tetrahedron, which is my personal favorite because it's hard to spell, and a wind tee. So there they are. So a windsock is pretty easy. One on one of the buildings around here at college. Wind blows it, tail points the building. You can see the tetrahedron down there. The tetrahedron is going to point towards the direction the wind is coming from. And then, oh, my slide doesn't work out very well. The wind tee has a big giant rudder or horizontal stabilizer in the back. Correction, or vertical stabilizer. Let's see if I can get this going here. This ought to really show a bigger vertical stabilizer. So the wind is going in this direction. With this tetrahedron, the wind is going this direction. And the wind tee, or correction, the wind sock, the wind is going in this direction. And they make these things big, and they usually put them near the center of an uncontrolled airport. When I say uncontrolled, I mean an airport that doesn't have a tower. Now, if it's big enough to have a tower, it's very possible, in fact, it's likely they'll have more than one of these. Usually, if it's a big airport, they'll put one near the ends of the runway so that when you're coming into land, you can see what the wind is doing down at the runway. And so I've been flying at an airport in Prescott, Arizona, and they had 3 of these on the airport, one in the middle of the airport, and then one on the end of each of the big, long, 6,000-foot long runway. And at that airport, all they did was use windsocks. So the reason you want to know about these windsocks is because it tells you which direction to land. We covered that yesterday. Does anybody remember which way do you take off as in relationship to the wind? You take off into the wind, so the wind will be blowing in your face. How about when you come into land? Which way do you want to land? With the wind blowing into your face. So it's good to be able to look at one of these wind indicators so you can decide which runway to taxi to. If you just started your engine, you're taxiing to the runway, and you're, well, should I go to this runway or that runway? You're going to look for the windsock, the tetrahedron, or the wind tee, and that's going to tell you which runway to go to. Yes? Why would you land with the wind? Why would you not do that? Because it's going to make you fly faster over the ground. And you want to hit the ground as slow as you can. Is it better or worse to take off and land into the wind? So let's try it like this. Let's say we have a 20-knot wind. And let's say we have an airplane. And velocity of rotate is 60 knots. So on this airplane, we lift up the nose at 60 knots. So if we have a 20-knot wind and the velocity of rotate is 60 knots, how fast is the wind going across the wing right now? When the airplane's at 0, this would be 20 knots. But what if the airplane is going 60 knots? Yeah, now we have an 80-knot wind. All right. So if we can lift off at 80, at 60, that means when the airplane's back here, when the airspeed indicator equals 60, how fast is our actual ground speed across the ground? It's 40 knots. So the distance right here to go from 0 to 40 knots ground speed, that's shorter than the distance to go from 0 to 60. So let's look at it. Let's try what you thought. Let's say the wind is going 20 knots in this direction. In order to get an airspeed of 60, Rodrigo, how fast is the airplane going to have to go across the ground? Well, think of it like this. If we're sitting here at the end of the runway and we're going 0 knots and we're not moving, our airspeed indicator would say what? It's going to say 0 because it doesn't read less than that. But in reality, the wind is actually blowing in the wrong direction across our wing. So our wind speed is really minus 20. So we have to go from 0 all the way up to, correction, here's our ground speed. We have to go from 0, we have to go up all the way to 80 knots ground speed just to get our airspeed indicator to say 60. So in one of these examples, we had to go to 40 knots ground speed, if we were going into the wind. But if we took off with the tailwind, we'd have to accelerate to 80 knots ground speed. Which of these is going to take a greater runway? Yeah, so this one's going to cause a longer takeoff roll. And it's also going to apply if we're coming in and land. It's going to make us land. Our airspeed indicator may say 60, but our speed across the runway is 80. We're going to need a longer runway. So what if this runway is only 1,000 feet? And what if it takes the airplane, if there's no wind, it takes 900 feet to get off the ground? We're going to be fine. But if we take off and the wind is blowing at our tail, now we may need 1,200 feet of runway just to get an airspeed indicator of 60. So we're going to be very unhappy in that case. So we're going to stay in this practice. We're always going to take off into the wind, and we're always going to land into the wind. And that doesn't even take into account the fact that it's going to wear out our brakes less. And all the other airplanes, they're all going to come in. They all want to land into the wind too. So we also want to land at an airport in the same direction that everybody else is going to land in. Because when one airplane flies into straight head-on with another airplane, it hurts a lot. Not for very long, but hurts a lot for a really short period of time. Has anybody ever had a mid-air collision? Straight in? No, me neither. Are you raising your hand, Jared? All right. So we talked about traffic patterns. Well, I don't know. He had his right hand up there like that. So traffic patterns. We've flown some traffic patterns in the simulator. I've drawn a couple. I'm going to go really specific here. Actually, what I want you to do, well, first let's cover these first two. In case you didn't write it down before, traffic pattern at the airport is typically 1,000 feet AGL. Let's see, Rodrigo, you asked me a question, so now it's my turn to ask you a question. What does AGL stand for? Above ground level. So that's not what your altimeter says. It's your altimeter minus whatever the height is below you. So at Reedley Airport, it's really easy. At Reedley Airport, the elevation is 380 feet. So what's the traffic pattern altitude at Reedley Airport? Probably it's in MSL. If we look at the airport and it says the airport is 380 feet above sea level, and we want to be 1,000 feet above the ground, then on our altimeter, that's in MSL, mean sea level, what does it need to read so that we're 1,000 feet above it? No, it doesn't have anything to do with 600. 1,380. So we want it to say 1,380. And that MSL, that equals 1,000 AGL. Okay. So typically also, if here's a runway, and let's say we take off, and we'll call this runway 33 because it's Reedley, and here's runway 15 because it's Reedley. If we take off this airport Unless we're told otherwise, we're going to make left turns. And we're going to make another left turn. And we're going to make another left turn, and we're going to make another left turn. Except at Reedley Airport, it does say something otherwise. It actually says, if you're taking off and landing on runway 33, it says to do right turns. It's there's one or two reasons. Either there's airplanes flying left and right over here, or there's somebody with a house down here that doesn't like airplanes over it, and it's a noise complaint. So just for fun, I think you'll be able to tell me. I think if I show you the aeronautical chart this time, you'll go, oh, yeah, that's why you don't want to fly that on that side there. Oh, no, the mountain's on the other side. The traffic pattern, actually, this tends to push you in towards the mountain. What's that? Valentino's Pizza. Oh, yeah, that's right. That's right that I mentioned that. But no, that's not it. Valentino's, if you fly right traffic pattern all the time, it tends to drive you over what used to be. I don't know if the Valentinos still live there, Mr. and Mrs. Valentino. I don't know if they still live there, but it's not because of a school. So there's Reedley. So I'm going to put in an aeronautical chart here. All right, so here's Fresno Air Terminal. Anybody ever see jets taking off and land out of the air terminal? You have? Okay, great. So there's one person that's seen airplanes take off and land out of the air terminal. Most of the time they land on runway 29, so their final approach is right around in here. In fact, we haven't covered it yet, but you can see the shaded magenta area. That means you have to maintain good visibility even closer to the ground, because IFR jets are going to be flying to come in here and land right around here. So if we look at Reedley Airport really close, let's get rid of that thing. Here's the runway. If we took off and we made left patterns, it would keep us right in here. So where am I flying if I make left patterns right here? I'm flying very close to the final approach where all these jets are going. So at this airport, if we look at the airport, I guess I got to put this back in. If I look at the information for the airport, and let's see, not the taxi diagram. Where does it say? No, that's not what I wanted. Where does it say it? Well, I'll be darned. It doesn't say it right here. Well, I didn't even look it up to make sure it said it, because it says it. Oh, now I know where it says it. This RP right here for Reedley Airport, right pattern if you're flying on runway 33. So this is runway 33 going up north like this. So that means after you take off, you would make right turns. And see, this will actually run you close to the mountain, Jaron. Not desperately close. So if it doesn't say right pattern, like for instance at Kings at Selma, does it say RP over here? No. So that means you make left pattern no matter what you're doing. But what it did say was that the traffic pattern was a different altitude. If it doesn't label it, it's a left pattern. And if it doesn't label it, it's 1,000 feet above the airport elevation. So the next thing I want to look at is the segmented circle. And you're going, segmented circle, what's that? So here's an overhead view off of Google Earth for Reedley International Airport. I got to stop calling it international. It's Reedley Municipal Airport. Municipal just means it's owned by the city. Question? Okay, so here's an overhead view, and here's the hangars. And let's see if we scroll in really close. Okay, sorry. We can't scroll in because it's not Google Maps. I pasted some pictures on here. I'm too used to using Google Maps. Because that hangar, that little shade hangar right there, that's where I keep my wife's airplane. However, you can see the runway here, and there's a 3-3 right here. It's hard to see. And then right up here, upside down, is runway 15. And there's this segmented circle right here. And this segmented circle, that's where they're going to put the windsock or the tetrahedron or the wind tee. So the next slide, I took a blow-up picture. This is off of Google Earth, and this picture isn't that new because this has a wind tee on it, and they've changed this to be a windsock. But you look at this segmented circle, and you're looking at this line, you pretend that's the runway. And if I was going to take off north on runway 33, you notice I'm not going to turn left. I'm going to follow this dashed line, and that's telling me to turn right and come in here and make right turns and land. If I was going the other direction, if I was flying south after I took off, if I wanted to stay in the pattern, I would make left turns. So even if I didn't notice that RP on the chart, then if I overflew the airport and looked down for the windsock and I saw the segmented circle, it would tell me. Question? Towered airports usually don't have this because you got to talk to the tower. Most uncontrolled airports do have it, but you usually are looking this up before you ever get to the airport. I never pay attention to the segmented circle because I've looked it up before I took off. Or if it's going to be a nice leisurely flight, I can look at it 30 minutes before I land. Like if I'm going on a cross country to Reedley and it's 2 hours to get there because I took off out of Los Angeles, I got 2 hours in flight. So I go, oh, it's about a half an hour before landing. I think I'll start looking at the stuff for the airport. Now, granted, if you're a brand new pilot, you're probably going to look at all this before takeoff because you're scared you're going to forget something. But after you fly for a while, you're not as scared that you'll forget something. So that is the segmented circle. Now what I want you to do is I want you to pull out that piece of paper that has the Reedley Airport on it, because I want you to draw on that document. So it's in the papers that I passed out yesterday. So most of the time at this airport, because of the wind is usually going from the north to the south. So if the wind was 330 at 10 knots, if that was what the wind is, then we would want to land into the wind. And the question now becomes, and this is the part I want you to draw, is what does a traffic pattern really look like? The traffic pattern is going to be about a half of a mile away from the side of the runway. So we want to go out this way about 1/2 of a nautical mile. I'm just going to abbreviate it nautical mile. Now I'm going to look at this runway, and this runway is 3,300 feet long. Now a nautical mile is just a hair over 6,000 feet. So 3,000 feet equals 1/2 of a nautical mile. So this runway is just a little tiny bit more than of a 1/2 of a nautical mile. So if I turned this runway sideways and I looked at this length of the runway, then that tells me that I need to come out to about there. And that's about a 1/2 a nautical mile, because that's the same distance as a hair less than the length of the runway. So that means when I'm coming up on the airport, I can estimate about where it's going to be. So that's going to tell me that a portion of the traffic pattern is going to be there. I can also look at it and say, if I took off and I turned right and went 45 degrees, I'd find a corner right there. And if I took off and I went 45 degrees, I'd find a corner right there. If I took off a runway 15 I'm going to take off, and I'm going to make this turn. Now, I was reading in the Aeronautical Information Manual, literally this morning, about flying around at an untowered airport, and it recommends, just to be clear, the Aeronautical Information Manual isn't mandatory, it's not an FAR. It recommends that you take off and make your first turn when you're 300 feet below the traffic pattern altitude. So what I've been telling you to do is climb until you're 500 feet above the ground level. It's saying go a little bit more. So if traffic pattern altitude at Reedley is 1,380 feet MSL, if I subtract 300 feet from that, then that's 1,080 feet. So this turn should be at 1,080 feet MSL. So I'm going to say that again. If you're at an on-towered airport, the Aeronautical Information Manual recommends, if you're going to stay in the traffic pattern and fly it around, you climb straight ahead until you're 300 feet below the traffic pattern altitude. So if the traffic pattern altitude here is 1,380, you subtract 300, that's 1,080. So that's where you know to make your first turn. So I'm going to fly, and go ahead, question? No, you're going to continue to climb, and you're going to level off when you get to traffic pattern altitude. So you might level off on this leg, and you might end up hitting this turn and turning. So here's the question is, where do I make this turn? This spot right here? How do I decide when to turn? And you make this turn, you're going to be flying in this direction. You're going to look back at the end of the runway, and when you see that it's a 45-degree angle back there, if you look straight out, and you look at that right there, that's 45 degrees. That's when you make your turn. Or you can also say, when this distance right here is a half of a nautical mile, that's when I make my turn. So you're estimating this. You're not getting out a ruler. You're not looking at your GPS. You're looking out the window and you're estimating it. You're going, hey, if I turn now, I'll roll out, and this leg right here will be just a little bit less than the distance of the length of this runway, because I know this runway is just a hair over a half of a mile. Now this leg right here, this leg has two legs. It's called the departure leg, or it's also called upwind leg. And it just depends on who's saying it, but both of them are correct. And that is, you're flying against the wind, you're flying upwind, or you could say I just departed the runway. That's why you call it the departure leg. All right, this leg right here, let's say the wind is going straight down the runway. So this leg right here is exactly 90 degrees to it, or you're going across the wind. This is called the cross wind leg. That's that right there. So if you heard somebody on the radio and they said that they were on the crosswind leg, and you were 2 or 3 miles from the airport, and you could see where the runway was, you could look up because you know where the crosswind leg is, and you could start trying to find them. Because that's what you're going to want to do, is try to visually identify anybody that you see or anybody that you hear in the traffic pattern. Yes, question? It doesn't have to be. You're asked a good question. The Aeronautical Information Manual is a thick book. It is recommended procedures. There's other places where it says they recommend it. Don't make your first turn until you're 300 feet off the ground. And then I found another place where it says don't make your first turn until you're at least 500 feet off the ground. The aeronautical information. So I was telling people, wait till you're 500 feet. That's a pretty good altitude, because if the engine quits, you got about a minute, and you can go about a mile if you turn a little bit. You still got 500 feet below you. But so you could turn at 300 feet, and nobody could say anything different. You could turn at 500 feet. You could turn at 1,080, you're 700 feet above the ground. So no, you don't have to wait until you're at 1080 MSL. If I'm in a hurry and I want to practice a lot of takeoffs and landings and there's nobody else in the pattern, I'm not going to wait till I'm 700 feet off the ground before I make my turn, because I'm paying $150 an hour for the airplane and $60 an hour for the instructor, so I don't want to pay $210 an hour to climb an extra 30 seconds. I want to turn and go practice another landing. But that's me. So the next leg that we're going to fly is this one. This is called the downwind leg. And you don't have to ride it sideways like me, but I hardly ever get to draw things sideways. So this is the downwind leg right here. It's called downwind because you're flying away from the wind. And usually that's what you call when something is downwind, is the wind has blown it that direction. So now your speed across the ground is going to be your airspeed plus whatever tailwind you happen to have. And again, you'll notice we want to be about a half of a mile away from the middle of the runway. Then you're going to end up turning another leg, and this is called the base leg. And again, the question becomes, where do you make this turn? How do you decide where to make the turn? And you could think of it as two different ways. Either I'm looking out the window and I see that if this right here is going to be 45 degrees, or you could also say, if this distance right here was a half a nautical mile. Either way, it's going to put you in the same place. And again, you're estimating this. And here's a really good reason why you need to always estimate this. Because this is the way you're going to fly if you're out in the middle of nowhere and the engine quits, and you look down at the ground and you say, that's a dirt road I'm going to land on. If you have enough altitude, like you're at least 1,000 feet above the ground, you're going to fly this whole traffic pattern. In fact, literally, you'll circle over that dirt road till you get down to 1,000 feet, and you'll fly a traffic pattern. Because guess how you're practicing your landings? In a traffic pattern. So how are you most likely going to do what you need to in case the engine quits to land on a piece of dirt that you want to? Is fly like you trained. And how are you deciding when to make that turn? You're estimating that it's a half of a mile. And after a while, you're not even going to be thinking about this. You're going to turn on a downwind and you're going to look at the runway and you're going to go, oh, I'm a little too close. And you're going to turn and to make yourself a little farther away. Or you're going to turn and get a little bit closer. Yes, if you have an engine failure and you make a turn, you're going to lose altitude in the turn more than you would if you were. Yes. So depending on where you are. If I'm right here and the engine quits, I'm going to land straight ahead. I might turn right a little bit. I might turn left a little bit. But I'm going to find a dirt road or a grape vineyard because I don't like to land in the trees if I can help it. And I'm probably not going to land on Frankwood. Frankwood, the road Frankwood goes right here. I'm not going to land on Frankwood because there's telephone poles and wires. And I don't like to hit telephone poles, and I don't want to get caught in a wire 50 feet above the ground and then fall straight down 50 feet and die. I really don't want to do that. So I'm probably not going to land on Frankwood. I know what's here. There's an orange grove. I don't really want to land in orange groves, but I'm going to put my fuselage between the trees. It'll break off the wings. I'll slow down really fast But as long as I can aim between the trees, I'm probably going to, everyone on board the airplane is going to survive. I'm just going to hit my head on the instrument panel because I don't have airbags in my 1969 airplane. You hit the, why do you fall 50 feet if you hit a telephone wire or power line? You hit it and it stops you. Or it slows you down and the airplane stalls. What do you do when the airplane stalls? You fall straight down. So even if I break the wire, if it slowed me down enough that I stall, I'm now going to fall straight down. I don't want to fall straight down. I hate that. I want to fall straight down that last 1 inch before as I hit the runway. That's the only time I want to fall straight down. Or if I'm practicing stalls and I'm at 2,000 feet above the ground. And then I don't mind falling straight down. Other than that, jumping out of an airplane, I haven't done that for a while, but there was moments when I was scared snotless about falling straight down. But I had a parachute and a spare. And I did it on purpose. And there was no power lines. Someday I'll tell you a story about trying not to, no, never mind, about jumping out of airplanes. So we've turned on the base leg. So the base leg, if I'm doing it correctly, this base leg is going to be a half of a nautical mile long. Just like this crosswind leg is going to be a half a nautical mile long. And we're assuming perfect conditions and a perfect pilot, and we're assuming no wind. And then I'm going to start this turn a little early. All these turns I'm going to start early so I can roll out on final. And this distance right here will be a half nautical mile. And this leg right here is called final. The final leg. If you called it your final approach leg, you could say that. Sometimes you just call it final approach. Question, Brian? No, what's really interesting is I read it and I looked it up on several different places, and the only place I could find where the FAA was trying to give you recommendations, I looked in the Aeronautical Information Manual and I looked in the pilot's Handbook of Aeronautical Knowledge, and both of them said the same thing. It recommended that you climb straight ahead until you're 300 feet below the traffic pattern altitude, and then start your turn onto your crosswind leg. And then when you're going to be a half a mile off the side of the runway, you turn on to downwind, and you fly the whole downwind a half of a nautical mile parallel to the runway. And then when you've gone past the runway. In fact, here's another place you ought to label, because you're going to want to do that, is this here. You'll notice that's when the airplane, and say, I'm going to draw a little airplane in here. So here's your little airplane flying along with the propeller. So right when you're straight across the end of the runway, that's called being abeam the runway. Now, if you coming in the lane, wow. So, and they taxi out the runway, or a cow got loose and there's a cow out there on the runway, or for any reason why you're not going to land, you're going to do what's called a go-around. You're going to give it full throttle. You're going to slowly get rid of the flaps so you can climb better. And if you, what you usually do is sidestep the runway. It's probably now that's what people would call the upwind leg, but you could still call it a departure leg. So in theory here, we actually have six different legs that you could call it. You know what? Let's not worry about this one here. Let's don't write this one in here, because it's still either going to be a departing leg or an upwind leg. So we have 5 legs and 6 different names, and then a whole bunch of other data here. Now, at the moment, if this seems really confusing, that's okay, because nobody expects you to know all this and do all this the first time in the airplane. Jonathan? When you enter the downwind, you want to be parallel. You want to roll out and be parallel to the runway. I'm not sure if I'm answering your question. So in theory, each one of these turns, you're making a 90-degree turn. And it's right traffic pattern at Reedley Airport if you're flying runway 33, so we keep making right patterns. But most airports that are uncontrolled, no towers, it's left pattern at all the runways at most airports. But most airports don't have big jets flying right next to it all the time. Well, your angle of bank, how far your wings go up, that's 30 degrees. So good question there. I wasn't being careful enough there. So your angle of bank is 30 degrees. So you do 30-degree bank turns. And so here's a really good reason to do 30-degree bank turns, because you're going to practice this over and over and over again. And you want to try to do as much of it the same as you did it every single time. So do it at 30-degree bank turns. So what are you going to do if the engine quits and you're flying a pattern to come in and land on a piece of dirt? How much are you going to bank the wings? 30 degrees, because you're going to in an emergency, you're going to act the way you trained to act. So train like you fight, so you'll fight like you train. Did I tell you that was an old Air Force saying? Yeah, okay, great. All right, so woohoo! Look at that. So we're going to take off, and we're going to turn onto crosswind 300 feet below traffic pattern altitude. Yeah, Jonathan. What about your paper? Yeah, you don't have delete on yours. I'm just trying to simplify it so I can go over some more material here. You're going to make a 90-degree turn here. So the angle of this turn, you're going to change your heading. Rodrigo, I said 90-degree turn. If you're going in this direction, your compass heading says 330 degrees. So you're going to turn right 30 degrees from that. So if here's 360 and here's 330, and we go 30, 60, 90 degrees, then this heading right here is going to be 060. So when you're flying in this direction, your compass or your directional gyro will say 060. But remember, on all those gauges, this last zero is gone. So that's what I mean when I say you're going to turn 90 degrees. You're changing the heading of the airplane. You're changing the direction of the airplane by this 90 degrees right there. So somewhere here on this base leg, so we'll call this the departure. Oops, can't do that right somehow. So this is the departure leg. And this is crosswind. Somewhere in here you're going to level off at traffic pattern altitude, which in this case is 1,000 feet AGL, which is 1,380 MSL. And then, when you're a half a mile out, you're going to turn, and you're going to fly downwind. You know what? I don't like where that downwind is. Let's fly a half a mile out, and then you're going to turn, and you're going to be on downwind. Now, typically what you do when you're beam the numbers, that's another way to call it, a beam the runway. If they have beamed the numbers, it's talking about that 3-3 that's written down here on the runway. So if I said that phrase, a beam the numbers, that's when I'm right there. So typically what you do at that point is you set the RPM to 1,500 RPM on the engine, and you put the carburetor heat to on, you, in the white arc, because remember, you can't put the flaps in unless you're slower than the top of the white arc. So that means you have to be less than velocity of flap extension. Remember that? If you're in the white arc, then half flaps, which in the Tomahawk is, I think it's 21 degrees. So you set the engine, you carb heat, you put the flaps in, and then you trim for the approach speed that the pilot operating handbook says, and in the airplane we're flying with 70 knots. So that's going to take you about 10 or 15 seconds. Now, just for fun, let's talk about how fast we're going. So we're going to fly down here until we're either at a 45-degree angle or we're a half of a mile past being the numbers, and we're going to turn on base. But I want to talk about how long is this base leg, how long is this crosswind leg. So when we're climbing, our best rate of climb in that airplane is 70 knots. Indicated airspeed, and we're not going to worry about the difference between indicated and true for a minute. If we were going 60 knots ground speed, that equals 1 nautical mile per minute. Right? So if you're in a car and you're going 60 statute miles an hour, and you do this for 1 minute, you'll cover exactly 1 mile. So this is a trick question. Think about it very carefully. If we were going 30 knots, how far would we travel in a minute? Half as much. So we'd go a half a mile. Let's do it the other way. What if we weren't going 60 knots, we're doing 120 knots? How far will we go in 1 minute? Twice as much. So what's twice as much as 1 mile? 2 miles. Okay. But 70 knots, that's really close to 60, isn't it? And we're pilots, and we like to do math where we can round it off and not have to do decimals and stuff in our head. Okay, you don't know that, but I know that. I don't want to do that. So I'm going to say that's about 1 nautical mile per minute. If this is a half of a mile right here, and I'm doing about 1 nautical mile a minute, how long is this leg? Yeah, just a hair under 30 seconds. All right, you're thinking like a pilot, a little bit less than 30. And that's from, now if we take into account the fact that there's some time in the turn, and there's the time in the turn here, we could actually say from the start of the turn to the roll out of the turn is going to be about 30 seconds. But let's just say this is about 30 seconds. But this turn, what about when we roll out? Because we're going to roll out and then we're going to say how long till we need to start our turn in minutes. Let's just say for fun that this turn takes 10 seconds. And this turn here is going to take 10 seconds. That means that this leg is only 10 seconds long, where we're straight, huh? But it's really, we really want to go a little bit longer than that. So we could actually say that we need to be about 15 seconds straight. From when we roll out to when we start turning is going to be about 15 seconds. I actually, in my airplane, I have an analog clock, an old school clock with needles that spin around like that thing up there. So I can roll out on a base leg and look at the second hand, and when it goes 15 seconds, I can start my next turn. Now, I don't do that very much because I'm used to looking out the window and looking at the runway. But what if I was at an unfamiliar airport? What if I was at a runway that was 6,000 feet long? 15 seconds would be really, really nice. So let me get back to where I was. Now, it may seem like I'm spending a lot of time talking about flying around an airport, but I'm telling you, has anybody ever driven a car on almost most of the class? How about driven a car in downtown Fresno? Okay. Or downtown Visalia. Yeah, downtown Dinuba doesn't count. All right. Is there a difference on how much you have to pay attention? Yeah, if you're on the freeway, you put on the cruise control, you set up your tunes, You pull out your ham sandwich and eat with one hand, and you pay attention so you're not a distracted driver. Your phone goes off and you don't answer it because you don't have a hands-free calling and you don't look at your texts. But you sit there on the freeway and you sing along, to old Beatles songs and eat your ham sandwich. We need a different sandwich. We've done ham, peanut butter, and jelly, and pastrami. What's the next sandwich? What? Turkey. Okay, I thought you said pickle. All right. So you got your pickle sandwich. Your turkey sandwich with pickles. You got your turkey sandwich. It doesn't take a lot of concentration, right? Everybody's going approximately the same speed except for the trucks. It's not that tough. You don't have to worry about stopping every 15 seconds and whether you're going to make a turn or somebody's going to turn and hit you, stuff like that. All right, so if you were going to teach somebody to drive and they lived in Fresno, how much of the time would you spend teaching them to drive inside of Fresno versus how much time would you spend teaching them to drive on the freeway? More time in Fresno. 51% in Fresno and 49% of the time on the freeway? Okay, Josh says yes. Rodrigo says 80% of the time in the middle of Fresno and only 20% on the freeway. I got a 70-30, I got a 75-25, but I think we could agree that since it's easier to drive on the freeway, maybe you need to spend more time training where it's hard. So when you're on a cross-country flight, it's not that there aren't some things you need to be doing, but you're not rushed. That's why you can get out your turkey and pickle sandwich. Okay, if you don't want the pickle, that's okay. You like the dark meat or the lighter meat, Josh? Okay, good, because I like the dark meat. So I'll eat the dark meat turkey sandwich, and you can have the white meat turkey sandwich. So when you're on a cross country, there's a whole lot less to do in any given minute. So that's why I'm spending more time at airports. It's actually less for you to think about if you fly into an airport with a tower. Because they're going to tell you what runway to land on. They're probably going to tell you how to get to that runway. They're going to tell you what altitude to fly. They're going to tell you where they are. Because the tower, everybody has to talk. Inside of the airspace around the airport, everybody has to talk to them. So they know where all the airplanes are. Yeah. Would you need more fuel? It is a question. It's possible that the airport is busy, that you'll be coming into land and the third or the fourth airplane, and they'll make you fly for an extra 1 or 2 or 3 minutes. So technically the answer is yes. But there's sometimes, like if you took on to Reedley and said and called up Fresno, I'd tell you to make a straight in, and you don't even enter the pattern. In that case, you might save 1 or 2 or 3 minutes. So in the long run, it's probably going to be about the same. It's not worth worrying about. I mean, I'm glad you're thinking. Don't get me wrong. I'm glad you're thinking. Yeah, when you're paying $18 every 0.1. So we're going to do one little math problem here. I know this is really tough. I'm going to make it really, really easy. So we're going to practice pilot math right now. Right now. Let's say your airplane costs $120 an hour. Okay, and 1 hour equals 1.0 hours. And a half of an hour equals 0.5 hours. You see how this is going? How much does the airplane cost for half of an hour? That's pretty easy. Half of 120 is pretty easy. But you could also do it by 12 times 5 and then move the decimal over. What's 12 times 5? 60. All right, sweet. All right, so what if it was what if it was 0.3? What if it was a third of an hour? How much would it cost? What's a third of 120? Yeah, a third of an hour equals $40. Okay. All right. Okay, a third of an hour, that equals 20 minutes, doesn't it? Okay. So how much is it per minute? $2 a minute? $2 per minute. for $120 an hour. Okay, so let's add $60 an hour for the instructor, and that's $180. So that turns this into 3. So when you're taking a flying lesson in a little tiny airplane, it's $3 a minute. I'm not trying to scare you out of flying a little airplane. If you take a Piper Tomahawk, and it goes about 90 knots or so, and you, instead of flying but it's a little two-seater, and it'll go about 300 miles plus some extra fuel for reserve. If you take a two-seat helicopter that goes about 90 knots, it's a Robinson R-22, and it'll go, it won't go 300 miles. Instructor, it's $320 an hour. Think about that. You're sitting there on the runway at the airport. Other planes are coming in and taking off and landing. Thinking, well, there's $3. If you're taking a helicopter, oh, there was a minute. That was $6. Yeah, don't think of it like that. You won't become a happy person. This is what you need to think of. That minute, that's going in my logbook. Yeah, that's going to get me my first job as an airline pilot or a corporate jet or a crop duster or as a firefighting helicopter pilot. You're going to go, yeah. Because every 6 minutes, that little Hobbs meter in the airplane clicks over a point. Every 6 minutes, 0.1. So every 0.1 in our little airplane at $3 an hour, 6 is $18 every 0.1. So you're just going to go, yeah, another point in my logbook. Another point in my logbook. Because you get to log your flying time from the moment the aircraft moves under its own power. So if they push you back, you know how the airlines, they push you out of the gate with a tug? The airplane's not flying yet. One could argue. I would argue it does, because are the engines moving? If they've started the engines, I say the airplane is moving. But little tiny airplanes, that little Hobbs meter, it's hooked up to, does anybody remember what that time meter is hooked up to? Yeah, it's hooked up to the engine oil pressure. So as soon as you start the oil pressure, you're not just paying for the airplane and the instructor. You're putting the log hours in your logbook. So you have to get over it. Okay, I think that's enough flying for today. So we're going to say that it's 25 after in real life. I'll tell you what. We're gonna go a little bit longer, and then in history, in careers, we're going to take 2 days to do an assignment. Can you guys hang out for another 5 minutes? No? Okay, yes? All right. All right, so a few more minutes. So base, we're going to turn to final. And typically what you do is, now remember, we're trimmed for 70 knots. We're going to make this turn on base, and typically right after we roll out, we go to full flaps. But we don't always go to full flaps. Right there, after you turn onto base, this is a really, really good time to look at the runway and go, is the airplane too high? Is the airplane too low? Am I right where I want to be? And if you're too low, put the flaps in. And if you're really too low, give it some more power. Give it some more engine power. If you're too high, put in the flaps. And if you're really too high, pull the throttle back. So really what you're trying to do is set yourself up every time as close as you can when you are beam the number 1500. Make sure your speed is in the wide arc, go to half flaps, and then trim for 70. But of course, this time you're already done eating your turkey sandwich, all right? So you pay attention. When you think you're at a half a mile past that point, or you're at a 45-degree angle off of the runway, you turn on base, and right when you roll out and you look over there at the runway, that's where you really, really make your first thought process. Am I too high? Am I too low? Or am I just the height I want? And you do something about it. Either add more flaps, you'll sink faster, or reduce the throttle, that'll make you sink faster. Because whenever you put in flaps and whenever you change the throttle, you're going to retrim it for 70 knots. Or that's if you think you're too high. If you think you're too low, wait to put the flaps in. You can actually land the airplane at half flaps. It'll be better if you practice it all the time at full flaps, because you fly the same way. And what are you going to do when you have to land off the airport? If you get more lift from the flaps, that means when you're landing and you're flaring, you'll be at a slower forward airspeed and you'll hit those orange trees even slower than you would otherwise. So you want to always practice to land with full flaps. So if you have an engine failure, you will land with full flaps. Question? Yes, you do what's called a no-flap landing. You pretend that the flaps broke, especially on an airplane that has electric flaps. Or what if the electrical system breaks or the electric motor breaks? In a Piper Tomahawk, the P-838, it's mechanically activated, so it's very difficult for that to break. We're going to do it if you... What happened? You're going to, when you flare, you're not going to sink as much, and you're going to go farther down the runway. But we'll talk about it. I don't think we're going to get to the point where we're talking about no flap landings in detail. Brian, what do you pay for? That's a good question. You pay for the instructor, and that's usually $50 or $60 an hour, the entire time that the instructor is with you, talking with you. And that includes in the airplane, that includes the briefing before you get in the airplane, and that includes the briefing after you get out of the lesson. So on a... Yes. But some of that time the instructor's not with you. So the way it would normally work is, you show up for a 2 o'clock lesson. You get scheduled airplane from 2 to 4. You show up about 1:30 or 1:45 to 2. You go to the receptionist and say, hey, my name is Rodrigo Acosta. You killed my father. Prepare to die. I'm sorry. Oh, that's right. The receptionist does not have 6 fingers on their left hand. So you say, I'm here to rent, I've got a 2 o'clock rental on a Tomahawk. And they look at it and they go, yeah. And they hand you the book and they tell you which one. So you go out there to the airplane and take your checklist and you do a visual inspection of the airplane. You check the fuel, the oil, you look around, make sure nothing's cracked, nothing's broken, there's air in the tires. There's a whole list of things. So that'll take you anywhere from 10 to 15 minutes, depending on what if it's low on fuel. You walk back in, you say, we need to call for gas. And they'll say, okay, I'll call them for you. Or they say, there's the phone. And you'll say, which gas company do you want me to call? But you've done this before. So you call for gas. And usually what I do is when I go check out the airplane, first thing I do is check and see if I need gas. Because I can be continuing flight inspection while I'm waiting. So this is going to take you 10 or 15 minutes. Gas at somewhere else or not? And how many trucks they have? At Reedby Airport, you have to taxi the airplane to the gas pumps. It's self-serve. Question? No, it's typically included in the rental fee. So, no, you typically don't pay for the gas. If you're renting the airplane and you go to another airport, like on a cross-country, flight schools do it one of two ways. Either they loan you the school credit card to pay for gas, or they say you pay for the gas when you're there, and when you come back, you give us the receipt, and we'll subtract that entire amount off of your bill. It varies by flight school. Most flight schools, they just use it. Because what if you show up there and now your credit card is denied, and your airplane is 200 miles away, and they don't like it? They don't really care that you're stuck 200 miles away. They care about their airplane. So you've been at the airport now for 20 minutes or so. You may make a phone call to the flight service station, or you may check the weather. How's the weather today? Can we go flying today? Okay, and you may listen to ATIS. You may ask for NOTAMs, which tells you things at the airport that's broken. So now you've been at the airport for 30 minutes. Boom, now it's 2 o'clock. Your instructor finishes with their previous student, and they say, yo, Rodrigo, what's up? And then you sit down for anywhere from 5 to 15 minutes, and you talk about what you're going to do in that lesson today. If you're a really good student and you don't want to spend lots of money, you show up ready to tell the instructor, we are on lesson number 15. Lesson number 15, we're going to do this and this and this, and the standard is plus or minus 100 feet, and the heading of the airplane is plus or minus 10 degrees. And then we're going to go do this maneuver. We're going to practice power on stalls and power off stalls. And on a power off stall, we're going to pretend that we're coming into land, and we're going to do it with full flaps. We'll do a clearing turn left and right to look for traffic, and we're going to trim it, and we're going to pull the nose up. And when the stall warning horn comes on, we're going to keep pulling the wheel back. The nose is going to drop, and when the nose drops, I'm going to release pressure on the wheel to start recovering from the stall, and I'm going to push forward on the throttle. I'm going to keep the wings level the whole time. I'll use rudder to keep the little ball coordinated. And as soon as I come up close to 70 knots, I'm going to start pulling the nose back and climb at 70 knots. So what you want to do, if you want to spend the least amount of money, is come in and prepare to brief to the instructor. Now, if you show up and you go, hey man, what are we going to do today? Because your instructor's name is Fred. Yo Fred, what's up? What are we going to do? They're willing to let you pay them $60 an hour to do about that lesson. Time you spend telling them how it's going to go, you still have to pay them. But you can go through it a lot faster. And they like that. Flight instructors would love for you to show up and be the best student they ever had. So now you walk out to the airplane, and so now that time, let's say that briefing took 10 minutes. We're just going to keep going here. Let's say we talk for that. Let's say we brief for 10 minutes. We go out to the air. Now the time comes. They're probably going to round it to 12 minutes, 0.2 hours. Because they charge you by hours, 0.2 hours, 0.3. They just round to the nearest one. This is the way it works. So you go out to the airplane, and you're climbing into the airplane, you're getting all your charts ready. They're going to walk around the airplane. They're probably going to check the fuel, and they're going to check the oil. They think you're a stupid pilot because you don't know what you're doing yet. No matter how good you are, they're probably going to walk around the airplane, and they're probably going to check the fuel and the oil. Because if you made a mistake, they're the pilot in command. While you're taking flying lessons, they're going to be the one. Okay, so that'll take about 2 minutes. They usually don't charge you for this. Now you get in the airplane, you run the checklist, they watch you, and the engine is started in about 60 seconds, in about 1 minute after you get in the airplane. Now the engine is on, the Hobbs meter is running, you're paying for the airplane, you're paying for the flight instructor. You go taxi out, you take off, fly around, do a bunch of maneuvers, you come back to the airport, you land, you taxi back, you park, and you turn off all the radios, and you shut off the engine. The instructor jumps out, and they leave you. This is after you've had 5, 10, 20 lessons. They leave you there to lock the airplane up and to tie the chains down and to turn off the electrical master switch. And then you write down the Hobbs meter time, and you bring it into the receptionist. In the meantime, the instructor is taking a nap, but you're not paying for him at the moment. You pay. You don't pay. You bring the book in, but you don't usually pay for it yet, because you still got to know how many. You got to sit down and debrief it with the instructor. The instructor debrief could take 10 minutes or it could take 15. If you're doing really badly, it might take them 20 minutes to explain to you how come you're doing so badly. And then if you're really, really smart and you want to spend the least amount of money, you say, Fred, Mr. Instructor, are we going to do, this was lesson 15, are we going to do lesson 16 next time? The instructor says yes. You say, okay, I'll be prepared. So you go home and you read up all about lesson 16, and you pull out the Airman's Information Manual, you pull out the Pilot Operating Handbook, and you read everything you can about everything in lesson 16. So when you show up, you know what you're doing. If they don't, you need to ask for it. And if they say, oh, well, we're just going to see how it goes every lesson, you picked the wrong instructor. Change your instructor. If you go to a flight school and they're not willing to hand you or sell you for $5 or $10 a copy that every single lesson, you picked the wrong place to flight train. Because it's just like, oh yeah, my name is Fred and I'm a flight instructor and I get paid. Now remember that $60 an hour, Fred's only getting about 20 or 30 of it. The rest of it goes to turning on the lights and the electricity and other things. And paying for the receptionist. And when you're done with your instructor, now you go see the receptionist and the instructor walks up there with you and says, oh yeah, it was 0.5 for me plus the airplane. And that 0.5 is 15 minutes of briefing before and 15 minutes of briefing after the flight. So if the flight was a 1.0, you would pay 0.5 for the instructor, an hour for the airplane, and then another hour for the instructor that they were with you in the airplane. Then if you're really, really good, you take lesson 16 and you go home to your flight simulator on your computer at home with your stick, and you fly flight number 16. So when you simulator, what you're going to do, on your computer, what you're going to do. There's a guy in the U.S. Navy in the year 2000 that did this. Did I tell you this story? Okay, well, good. I got 22 minutes. This is worth telling you. This is important. In the year 2000, there was a Navy pilot in Navy pilot school. And all the Navy and Marine Corps pilots train at Pensacola, Florida. It's on the panhandle of Florida, it's at the Gulf of Mexico. All right. So he was the best student that his flight instructor ever had. And one day his flight instructor said, it was like 20, 30 lessons in, "Man, you're the best student I ever had. I'm just so glad you're a great student. I wonder why you're so good." And the student says, "Oh, it's because I go back to my dormitory room every night, and I use this game called Flight Simulator 98. Remember, this was the year 2000. So Flight Sim 98 comes out, and it turns out they ask some more questions. He goes home every night, and he calls up on his big old 75-pound computer screen, with a resolution of that 640 by 480, and his desktop that weighs 28 pounds, and he's got a stick and a little throttle, and he's got the lesson plans for all the lessons. And he goes, "Oh, I'm flying lesson 16 tomorrow. What am I going to do? Oh, that. Well, I'm going to go give it a try." And he would set the computer to take off out of the Pensacola Naval Air Station, and he would set the airplane to the same kind of airplane that he was flying in flight school, and he would go practice the maneuvers. He would read up on how to do it. Oh, this is how you do it? And he probably wasn't doing it right. He goes, "Well, I got to if I'm going to do a stall, I'm going to pop the stall, throttle to idle, and I got to nose back until the stall warning horn comes on, and then the nose is going to drop, and then I'm going to let go, I'm going to push forward, and I'm going to give it gas." Okay, so he got 4 things right out of 6, yay. So he would practice it, and then he would fly back to Pensacola. And then the next day, he was way ahead of everybody else. So this was the year 2000. 2 years later, the Navy did a study. They built their own simulators. They got chairs and a throttle and a control stick and a throttle, just like in the airplane, and they set up a 55-pound cathode ray tube, 40 by 480 resolution, with Microsoft Flight Sim 98 in it. And they took a group of students, I don't know how many it was probably 30 or 50, and they trained them all on this simulator, like this other pilot had done, but they made it formal. And say, "Here's the lesson, we're going to show you how to do it," and they did it. Guess what? Students learned faster and got good in less amount of flying time, and they had lower failure rates on their check rides. So guess what the Navy did after that? Simulator time. Let's see, what year was it? It would have been about 6 years later, in the year 2008, when I was still working at Embry-Riddle Aeronautical University. One of my students that had graduated, he got in the United States Marine Corps, and they gave him a pilot training slot. He went to Pensacola, Florida, where all the Marines and the U.S. Navy pilots learn how to fly. And he finished. It takes a year. He was traveling across the country after he just got out of pilot school with his brand new gold Navy wings. And he goes through Prescott, Arizona, because he's going to Lamar Naval Air Station, because he's going to fly F-18s for the Navy and the Marines. That's where the Navy and the Marines teach their pilots how to fly F-18s right after they get out of pilot school. He comes by Prescott to see his old professors, and he comes in my office. "Hey, Professor Johnson, how you doing?" And I said, "Well, you're a pilot. You can call me John." And he tells me about pilot school in the United States Marine Corps, which is also the pilot school for the United States. Half of their flying was in simulators. Only half of their flying was in real airplanes. So a year later, I quit my job and I go to work for helicopter flight school. The boss says, "I want to reduce training to cost the students by 18%. Okay, simulators. We spent $100,000, and we built 7 simulators, very similar to those, except we built them to work on a helicopter. We spent $100,000 in the first 3 months I had that job, and we were training people on it. and the average student that was getting their private pilot certificate in a helicopter was taking 80 hours. A year later, we had that down to 65. We shaved off 15 hours to get their private pilot certificate. Remember, $320 an hour, what's 15 hours? Well, 3 times 15 is 45. That shaved off $4,500 for people to get their private pilot certificate. At that altitude we were, the little two-seaters you couldn't fly to take your instrument rating, you had to rent the four-seater. It's $600 an hour. We shaved off 20 hours. 20 times 6, 2 times 6 is 12. We shaved off $12,000. Holy crap. So, when somebody tells me you want students to spend less money to learn how to fly, you want them to be better at it and be more likely to pass a check ride, I'm going to tell them you need to teach them how to do stuff in the simulator before they do it in the airplane. So whether or not, and there's books you can buy right now that tell you how to fly a simulator, a game, a $50 video game, but use it to become a better pilot. There's a guy named Rod Machado, M.A. If you want to write this name down, you can look him up on the internet. He's awesome. He's probably the most famous civilian flight instructor that ever lived. His last name is Machado, Machado. His first name is Rod, R-O-D. And he wrote an article about it. And if you go to his website, I think it's machado.com or something like that. And he says, if you want to learn how to be a private pilot in civilian airplanes, here's what you ought to do. You ought to go to the FAA website and download the booklet and print it out, and it's got all the maneuvers you have to do to your private pilot check ride for the flight test. And then you go to a flight school and you find a flight instructor and say, I want to pay you to come to my house and show me how to do all these maneuvers on my desktop video game with a $50 control wheel and a set of pedals and a set of throttles. So it's going to cost you, not including the computer, it's going to cost you $250. But oh wait, that's the cost of one flying lesson. By the time you do the post-flight briefing with the instructor, those flying lessons in little two-seat airplanes are between $200 and $250. Just one lesson. You pay him, whatever they'll take, and of course he makes a lot of jokes. He'll say to make from pie and cake and whipped cream and stuff to get him to come to your house. But get him to come to your house and show you operate the computer on how to operate the game. What airplane are you going to fly? But you guys have done some of that, right? You've picked different airplanes, right? Okay. So, learn how to do that. You get your flight instructor, pay him $50 an hour or whatever it is, and say, let's go through the Airman Certification Standards, the ACS. That's the book that's got all the maneuvers you got to do in the airplane. And say, okay, show me how to do this. Not to where I'm great at it, but at least show me in the airplane how to do it. Okay, let's do a takeoff. Oh, you got to give it more right rudder. Okay, you got to give it enough rudder to go straight. Well, here's the airspeed you ought to climb at. Okay, let's fly the traffic pattern. Show me a traffic pattern. Show me how to do a power on stall. Show me how to do a power off stall. Show me how to practice an engine failure. We haven't talked about yet. So it's not that you're good at any of these things, but you just practice 2 or 3 maneuvers and you pay $50. You paid a week, pay them $50, do it again. And you do this 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Let's say you do it 10 times. Now you're paying $50 an hour. So that's $500 for the instructor, and let's say you're out $250 for the computer game and the control wheel and stuff. So now you're out $750. How many flight lessons do you have to get before you broke even on your $750? 4. 3 or 4 lessons. So if all you do is shave off 4 lessons, and most flying lessons are about 1.2. So 4 lessons times 1.2 is 5 hours of flying. If you can reduce your flight training cost by even. What if you could shave off 10? What if you could shave off 15? Let's just say for fun, you shaved off 10. 10 hours where you spent the cost of 5, but you shaved off 10. So that means you saved 5 lessons. 5 lessons. just saved up $750. You know how much it costs to pay for your flight fee when you go to the DMV to get your driver's license? How much do you have to pay the DMV to get a driver's license? 10, 20 bucks? I don't know what it is. Okay. Test, examiner, $600. Plus, you have to pay to rent the airplane. Yeah, it's fun when you say, ho, ho, ho. No, they're not Santa Claus. And Santa Claus isn't going to give you $600. Yeah, but I would have said holy mackerel or some other explicative other than mackerel. Yeah, $600. Wow, but I just saved $750. I just saved enough to pay for my examiner. But what really paying attention to what you were doing, what if you shaved off 15? It's an extra $750. Now I saved $1,500. Or what if you went to a flight school where they had a structured, organized simulator program? So every week you come to simulator flights. And they had open lap hours you could come in and practice an extra hour or two a week. The way Reedley College is going to do it, if I'm still working here then, is that first week of school, the first 2 weeks, you can drop your classes and get a 100% refund at Reedley College. So guess how many students are going to go to Fresno and fly real airplanes during that first 2 weeks? If any student can drop and owe the college $0, you think the college is going to put anybody in an airplane that first 2 weeks? No, they're correct. They're not. So what are you going to do that first 2 weeks? You're going to start going to ground school, take some other aviation class. But what your instructor for the flight course is going to do is going to say, here's the times you show up at the computer lab, and we're going to do a 90-minute lesson every day, Monday through Friday, for the first 2 weeks. Now, that 90 minutes, you'll probably be on the simulator about an hour, because you'll do a pre-flight briefing, you'll fly it, and then you'll do a post-flight briefing. Now, granted, the instructor's, is going to be training 6 or 7 students at once. And that's not as good as one-on-one, but that's it at your house, right? And nobody's watching you at all. So you're going to get 10 one-hour lessons. And then after the first 2 weeks, but that first 2 weeks, you're going to have been practicing takeoffs and landings and flying traffic patterns. And since you're going to learn how to fly at Fresno, the instructor is going to teach you how to talk on the radio. And here, let's have the aircraft initialize at JB Aeronautics. So you have to call ground control and taxi out to the runway, and then do it and have the exact same checklists or at JB Aeronautics or wherever you're going to fly. So by the time you get these 10 lessons, you've done taxiing, you've pretended to talk on the radio, you can take off and you land, you can fly a traffic pattern, you can fly away from the airport and go to a practice area and pretend you're talking on the radio, and you can turn around and you're going to practice coming back in and talking to the tower and figuring out how to fly inside of when the tower is talking to you. So that way, when you get to that airplane, you've already done all these things 2, 3, 4, 5 times. Then after that first 2 weeks is up, you don't come in and do a simulator flight every day. You knock it down to just once a week. And all you have to do now is once a week is have one simulator flight and stay ahead of whatever you're doing out at the airport. So every time you go practice something in the airplane, in the real airplane, you've already done it in the simulator once or twice or 3 or 4 times. So that's Mr. Johnson's how do you not spend as much money becoming a pilot deal. And it took me 20 years to put all of that together. The job I had, since I let you go too early, the job I had before I went to work for that helicopter flight school, I worked at Embry-Riddle Aeronautical University. It was a 4-year. Tuition is $15,000 a semester, and that doesn't count the flying. Yeah, I know. It's like, man, yeah, you can say an explicative there if you want to. You don't know what explicative is? That means a naughty word, a curse word. All right, it's probably up to 16 or 17,000 now, because it was 15,000 in 2009 years ago, so it's probably 16 or 17. All right, so there, I was in charge of a degree. I had a lot of pilot classes in it, but you didn't have to fly in it. But I was teaching the classes that were in the degree that the pilots took. I taught airframe systems, electricity, and hydraulics and stuff like that. And I taught a class jet engine for pilots. And I taught safety, and I taught how to be a flight instructor. I taught a multi-engine class how to fly twin-engine airplanes. In any case, students would be flying in the degree to be a pilot, and then something would happen and they weren't going to be able to fly anymore. They ran out of money, or they didn't want to fly, or they were in their last semester and they still wanted to graduate, but they couldn't fly anymore. So they would come to me and see me, and I would give them advice about getting to this other, in charge of this other degree. So for 10 years, about 30 or 40 students a year would come in my office and tell me why they weren't going to fly anymore. And sometimes it's because they ran out of money, but sometimes it was other reasons. So I heard all the reasons why people were leaving the flight training program. So I did that for 10 years. And then before I got that job at the helicopter company, the reason I got that job is because the boss came to me one day. He had known each other for 5 years. And he said, I want you to quit your job at the university, and I want you to come to work for me, and I want you to reduce cost to students. And so I thought about it for 6 months. I did some more research. I wrote up a plan that said we got to spend $100,000 and make simulators. And he looked at it and he said, okay. And I said, okay. So I turned in my letter of resignation, and I did that for years. I was the guy that was in the simulator lessons and how does ground school go and all that stuff. So I've given you 80% of my secrets on how to do well in flying. You want 15 out of that last 20? You got 5 more minutes. You can't leave anyway. Okay. So all right. Okay. All right. Half of the students who fail their check rides, fail because they don't pass the oral exam. You know, they may get to come back and do it again. So if somebody says, keep your knee. Yeah, we're going to watch this tomorrow. But there's a thing called grit. Grit is determination, perseverance, motivation over an extended period of time, not just working really hard today, not just for a week, not for a month, but months and months, maybe even years long. Like you got to have perseverance. You got to get through high school, right? How long do you have to work at it to get through high school? 4 years. Well, some of you in here might take you 5 years, but that's a whole other story. I don't feel bad. It took me 9 years to get my bachelor's degree, so I don't feel too bad. I mean, I wasn't in school the whole time. So, in any case, the number one quality that you need to become a successful pilot, even a private pilot, but even more so to become a commercial pilot, is you have to be willing to work hard day after day, week after week, month after month, year after year. And to me, that means you have to want it bad enough to shove your nose into the grindstone and keep spinning it a lot. Not that you don't get to take some time off, but it takes a lot of studying, and it takes more studying, and then you got to study more. And then it's been 6 months, so you got to study it again because you forgot a third of it. So 15. I'm going to watch a 6-minute video tomorrow sometime, I think, about grit, and it's about determination, motivation, and perseverance. And the good news is you can get more of it. You can practice and get more of it. But think about the things. I still got 2 more minutes, so you have to put up with me. I love it when I have an audience that can't run away very easily. Is think about life when there was something you wanted, and what were you willing to do for it? So that's what I want everybody to do for the next 15 seconds. I want you to think about something that you wanted, and it was hard to get, and you had to do something you didn't like to be able to do it. Does anybody have an example that you want to share? I can give you an example I wanted to share. Go ahead. Your electric guitar. You wanted one. So what did you have to do to get an electric guitar? Okay. So you didn't want to sell that stuff. Okay. So it was an emotional difficulty. Okay, but it wasn't going out making ditches for a month, 10 hours a day difficulty. It was, oh, okay, so you also got a job digging. Oh, okay. Where? Fire department. At the fire department? Had ditches in their backyard? Okay. All right. When I was in the Air Force, they let me go to officer candidate school so I could be a navigator, and my pay doubled. I had to go to 12 weeks of officer candidate school. I hated officer candidate school. I hated every day of it. Some people liked it. Some people, it's okay. I disliked it a lot. Mostly because I was really bad at officer candidate school. That's a long story, and I've only got a minute. But I graduated at the bottom of the class of about 300 officers that graduated with me at the same time. I graduated 99 out of 300. I'm not kidding. I was at the bottom of my class. Huh? I graduated. It's like, what do you call a doctor who graduates at the bottom of their class? Doctor. You call them doctor. Yeah, even if they were the worst student, as long as they graduated, they still get to get called doctor. But every day was a struggle for me to get up and do all the stupid things they wanted me to do, because I didn't want to do any of them. I didn't want to do any of them every day. And I was bad at it. I was staying up late. I was climbing in my closet and putting a blanket over my head and turning on a flashlight to study. Because they would walk around and crack open the door in your room to see if the lights were on. So I'd go in the closet and shut the door and then put a wool blanket over me. I was behind on my studying. So I was sleep deprived most of the time. In fact, of everybody I knew in officer candidate school, I got more demerit than everybody else. In fact, if you didn't include one person, I got more than everybody else. Of the 15 people in my training group, I got more demerits than 14 of the people added together. Because I was horrendous at it. I got better. So for me, it was my determination and my motivation and my perseverance. Of course, I also could look at it and go, 12 weeks. Okay, this will suck for 12 weeks, but then my pay will double, and yay, I'll get to go to navigator school, and that's going to be fun. And that's a whole other story. Navigator school was a blast. Hope you guys have a good day. I'll see you tomorrow. And remember, the essay is due on Thursday next week. That's 8 more days.